Next, we'll cover the rear wheel tapered axle shaft bearings, but before we move to that, we'll start with a general overview of rear axle bearings. There are several different types of rear axle bearings and assemblies. In this course, we will cover a few of the most common designs of solid drive axles and the bearings that are used. These drive axles can be either semi-floating or full-floating designs and are distinguished by how they handle the weight of the vehicle. Most semi-floating axles can be found in automobiles and light trucks. The axle is designed so the weight of the vehicle passes through the axle bearing to the drive axle and onto the wheel and tire. It consists of an axle shaft that is splined on the inner end where it mates to the differential and has a wheel flange where the wheel studs mount at the other end. There are two semi-floating axle designs. The first design is often called a C-lock retention type because the axle shaft is retained by a C-clip lock inside the differential assembly. This design typically incorporates a cylindrical bearing. The cylindrical bearing consists of an outer race and straight rollers. Cylindrical roller bearings are a good solution for heavy radial loads and minimal thrust loads because these bearings have a high rolling contact area and they are well suited for axle shaft bearings. This axle type will be covered in the cylindrical roller bearing section of this course. The second semi-floating design is called a flange-retained axle type. This style uses a retaining plate to lock the axle shaft to the rear axle housing. The bearing can be a cylindrical roller bearing pressed into the axle tube or a tapered roller bearing pressed onto the axle shaft. The tapered roller bearing type will be covered in this section of the course. The cylindrical roller type will be covered in the cylindrical roller bearing section of this course. The other common axle type is the full floating axle, where the axle drives the wheel but does not carry any of the vehicle weight. The spindle is attached to the outer end of the axle housing. A wheel hub is mounted on this spindle and rides on tapered roller bearings. The wheel hub assembly carries the weight of the vehicle. A full floating axle assembly is considerably stronger than an equivalent-sized semi-floating axle. In all of these designs, a separate seal is used to retain the grease or oil. These seals should always be replaced when performing any of these services. We'll start with the semi-floating axles. Before you begin, be sure to follow the vehicle manufacturer's recommended procedure to remove the tire and wheel. Detach any retaining clips or bolts holding brake rotors or drums to axle shaft flanges. Remove the brake rotor or drum. Remove the nuts holding the retainer plate to the backing plate. Grip the axle shaft flange with a puller or slide hammer if needed. Remove the axle shaft and bearing assembly. Inspect the old bearing cone and cup for nicks, pitting, and damage. If there is any damage, the entire bearing must be replaced. Note how the old seal and flange are positioned on the axle shaft. Tip: never install a new bearing cone with a used bearing cup or vice versa. Never reuse seals. Contamination entering past an old or used seal will ruin a bearing. To replace a bearing cone, retain the axle shaft from moving. Use a suitable cutting tool to cut one or more grooves in the retaining ring. Use a chisel and hammer in one of the grooves to crack the bearing retainer. Be careful not to damage the axle shaft. Slide the loosened retainer from the shaft. Repeat the same process on the bearing cone. Remove the loosened cone from the shaft and discard it. To remove the bearing cup, pull the cup out of the housing. A bearing removal tool may be required. Now we'll review bearing and seal installation for rear wheel tapered bearings for semi-floating axles. Start by inspecting the axle shaft for burrs, nicks, or other damage. Carefully smooth out any roughness with an emery cloth and clean the axle housing cavity. Next, pre-lube the seal with the same lube as contained in the differential. Put a light coat of wheel bearing grease on and around all surfaces of the bearing. Then slide the flange, new seal, and bearing onto the axle shaft, making sure they are in the same position as the old ones were. Using a press, install the new bearing onto the axle shaft. Only apply pressure to the press-fit portion of the cone. In this case, the inner race is press-fit. Then press on the bearing retainer. Carefully slide the axle shaft into the axle housing. Make sure the bearing and seal are properly seated in the axle housing. Install the retainer plate over the axle housing studs and torque the securing nuts to the vehicle manufacturer's recommended specifications, typically 35 foot-pounds. Finally, install the rotor or drum and follow the vehicle manufacturer's recommended procedure to replace the tire and wheel. Tip: only use high-quality wheel bearing grease on the rear axle bearings. Never install a new bearing cone with a used bearing cup or vice versa. Now, let's cover bearing and seal removal for full-floating axles. Be sure to follow the vehicle manufacturer's recommended procedure to remove the tire and wheel. Remove the retaining bolts that attach the axle shaft flange to the hub. Then remove the axle shaft and O-ring or gasket from the axle tube. It is best practice to replace the O-ring or gasket. Next, remove the hub nut. Then remove the hub from the axle housing tube and place it on the workbench. Remove the outer bearing. Remove and discard the oil seal, being sure to use the proper oil seal removal tool to prevent damage to the hub. Tip: always install a new hub seal after removing the hub from the axle. A damaged or worn seal can permit bearing lubricant to reach the brake linings, resulting in ineffective brake operation. Now let's review cleaning and inspection procedures for rear wheel tapered bearings for full floating axles. Begin by removing oil and dirt from the hub cavity and the axle housing spindle. Inspect the bearings for evidence of nicks, pitted areas, damage, or metal particles in the oil. If any of these are found, discard the entire bearing and replace it with a new one. Pits, nicks, and particulate contamination can lead to advanced spalling, breakdown of the bearing, and noise. Reusing the bearing in any of these circumstances will create additional harm to any new components, as well as early failure and continued noise. Next, inspect the cleaned bearing cups in the hub thoroughly for nicks, pitted areas, and damage. If any of these are present, remove and discard the entire bearing set and replace it with a new one. If removal is required, use a press or race removal tool to remove the bearing cup from the hub. Tip: never install a new bearing cone with a used bearing cup or vice versa. Inspect the axle housing spindle for burrs, nicks, embedded particles, scoring, bending, thread, or other damage. Follow the manufacturer's recommendation for acceptable spindle wear. Finally, let's review the bearing and seal installation process for rear wheel tapered bearings for full floating axles. Start by dipping the inner bearing in a container of the appropriate gear oil. Then install the inner bearing into the hub. Next, lightly lubricate the seal ID with gear oil and install the oil seal with the proper seal installation tool. Then install the hub onto the axle housing spindle, being careful not to damage the seal while pushing the hub into place. Tip: before installing the outer bearing, fill the hub with the appropriate gear oil until the oil runs over the small radius of the outer cup. To protect the spindle end threads while installing the hub, wrap them with electrician's tape. Once the hub is installed, remove the electrician's tape. Then, dip the outer bearing in a container of the appropriate gear oil. Install the outer bearing into the hub and install the hub adjusting nut. Follow the manufacturer's torque specification procedure. Using a Ford with a Dana axle as an example, you would torque the hub nut to 70 foot-pounds while rotating the hub by hand. Then you back off the hub nut 1/4 turn and retorque to 18 foot-pounds. Finally, install the axle shaft and new gasket or O-ring and secure the axle shaft flange to the hub with the retaining bolts. Again, using a Ford with a Dana axle as an example, torque the axle retaining bolts to 98 foot-pounds. Be sure to torque the bolts in a star pattern. Tip: to prevent leakage from the flange holes, a non-hardening sealer should be used on the bolt threads. Complete the installation by installing the rotor or drum and follow the vehicle manufacturer's recommended procedure to replace the tire and wheel. Check the differential oil level and top off as needed. To close out this section of the training, let's review some general items on rear axle tapered roller bearings, starting with general service information. The general bearing end play setting is 1/1000th to 7/1000ths of an inch. Tapered roller bearings are often reused. Seals should never be reused. Only use correct gear oil and additives. Do not mix old and new parts. Finally, we'll review common causes of tapered roller bearing failure. Improper preload adjustment. Incorrect gear oil. Low oil level. Contamination. Mix of old and new parts. Improper press fit of bearing. Use of low quality or value grade parts.